Hello, Algebra 3 students. This is Lesson 1-4, dealing with linear functions and models. Again, dealing with linear functions is a little bit different than dealing with linear equations, and it's all about the notation and the way we state it. So if we go ahead here, in your notes here, a function describes a dependent relationship between quantities. So just like what you do for schoolwork is kind of dependent on what day of the week it is, that's a relationship of a dependent relationship. For instance, the value of some x expression's value depends on what you put in for the x value. Okay? And we kind of read this aloud as saying that 2x plus 1 is a function of x. And to get the word function involved with the kind of equation writing, this is the notation that we use here. So this is written as f of x equals 2x plus 1. So the function of x deals with 2x plus 1. Okay? So we've seen this before. This is used a lot when we're doing relationships or modeling or even graphing. So moving on. Now here, if my function is this function here, and I'm asked to evaluate a function at some values here, if I say my function value is 1, that means I plug a 1 there and I evaluate. If I say I want to find my function's value at 0, f of 0, we plug in a 0 there and we calculate. If I want something a little more difficult per se, the function at negative 1/2 means I plug in wherever there's an x, in this case just one spot, negative 1/2 there. Okay, so a key thing here, if a function of a number equals 0, then that number is called a 0 because it equals 0, not because we plug in a 0. And if we use f here, we're going to use f here. If this was a t, then this would be a t. So kind of like a function name here. So now, to language here, we'd simply say that f is a function of x here, combining the inside variable with the function name. And in this case, r is a function of t. Alrighty. So again, just the way that we write it, the way that we state it. Moving on here. So we have one example as far as modeling. The senior class is renting the Lacrosse Center ballroom for $400 for their fall festival dance. So that means this is a pay. We got to pay that out. Tickets for the dance are $8 per person. So this is a kind of pay in. So that's the money that the dance or the group will take in. Express the net income I as a function of the number of tickets sold. So right away I know my function's name is this and my dependent variable is that. And again, I can start with I'm down $400 plus I'm taking in some money. So that's why my take in is positive and this becomes negative. Now I could have written it 8n minus 400 if we wanted. So now it's asking us to graph the function. And this grid here is, if I go ahead here, I'm going to go ahead and put the horizontal axis here. And I'm going to put the vertical axis here. And I'm going to call this negative 400. Okay. And I'm not sure what I I need to do, I know my y-intercept equals negative 400, and my slope is 8 over 1. So I went by hundreds this way. I could go by, let's go by 40s this way. Okay. So if I go by, I don't know how I want to do this here. Well, I could go up 8. 1, 2, 3, 4, 5, 6, 7, 8, and over 1. 1, 2, 3, 4, 5, 6, 7, 8, and over 1. Okay. So now here's kind of the function. It kind of does this if I'm graphing the whole thing. Okay. But the key thing here is I can't sell negative. I guess I can. Alrighty. So let's just leave it at that. Now the last part here, it says how many tickets must be sold for the seniors to be beginning to make a profit. So that means I want to know when 8n minus 40 is to be greater than 0. I'm going to add the 400 over, divide by 8. So my number of tickets has to be more than 50. So I would just say more than 50 tickets sold. So like 51 tickets, 72 tickets, 111 tickets. So again, with this, you just have to set up your equation. Sometimes you'll be asked to graph, and sometimes you'll be asked to answer a question concerning the relationship here. Well, that's about it. Here's the assignment. Work on the worksheet, all of them, and bring questions to class next time I see your faces via whatever format. Hopefully this helped. Stay well, and we'll see you soon.